quick example of verifying an identity. So we want to verify that tangent of 2 theta is equal to 1 divided by the quantity cotangent of theta minus tangent of theta. And I went ahead and I brought along the double angle formula for tangent because I figure we may need this at some point. All right. So to verify this identity, I'm actually going to start with the right-hand side of this identity. So if I start with 2 over cotangent of theta minus tangent, I'm going to rewrite cotangent of theta as 1 over tangent of theta to get started with. And one reason why I'm doing this is because I'm allowed to. It's a reciprocal identity. The tangent is 1 over cotangent, or cotangent is 1 over tangent. Why I want this in terms of tangent instead of maybe sine and cosine this time is I notice that this is kind of where I want to end up, is 2 tangent of theta over 1 minus tangent squared of theta. If I can make it look like this on the right-hand side, then we can replace it using this double angle formula with tangent of 2 theta. So that's why I kept everything in terms of tangent from the beginning, because I see the formula has tangents involved instead of sine and cosine. The next thing I'm going to go ahead and do is I don't like having fractions within fractions. So I'm going to go ahead and multiply both the big numerator and the big denominator each by tangent. The idea being that if you multiply by the same thing, numerator and denominator, like tangent over tangent, that's like multiplying by 1. So it's not really changing the value. It's just making it look different. So in multiplying by that, you can see that our numerator is now going to be 2 multiplied by tangent of theta. So that's looking promising. Just kind of spine where we want to end up over here on the right-hand side. And then we're going to have to distribute for our denominator. So this tangent of theta gets multiplied by each one of these, the fraction. So tangent of theta multiplied by 1 over tangent of theta is going to give us just 1. Bring along our subtraction sign in between. And we have tangent of theta multiplied by tangent of theta is going to be tangent squared of theta, or tangent of theta squared. And you're going to notice now that this looks exactly like what's over on the right-hand side. So based on the double angle formula, we can finish this up and we can replace all of this is equal to the tangent of 2 theta. And we have it. It equals the left-hand side. So we're done. All right, I hope this helps out. Sometimes it's nice to just bring along whichever formula you think you're going to need. So you sort of have this peek into where you want it to end up looking like this 2 tangent of theta over 1 minus tangent squared of theta. Hope this helps. Good luck.